class. So I will go on what comes for gate generally. What are the topics that comes for gate? Okay. So first of all, the topic here is differential equations, and we are doing gate, right? What is important for gate? Those topics only we are covering. So differential equations. Differential equations. Let us see one by one. Now, what is the purpose of differential equations? This is the last class which we had done. These are the three books which has to be referred. Both I will show. So, Higher Engineering Mathematics by Irvin Krejcik, Higher Engineering Mathematics by B.B. Ramana, and Higher Engineering Mathematics by Greva. These are the two things which we have to do. So now let us see where are differential equations used, why it is used. See, generally when you are told about differential equations, people who teach you differential equations are generally mathematicians. So the approach in which the mathematicians teach is different, and the way the approach in which engineers teach is different. So we are going with the engineering concepts. Okay. Now differential equations, when I say, okay, one of the best example of a differential equation, we will go directly with that example of a differential equation. What would be the example? One best example, can you tell me? A stone falling. This is very important. Okay, stone is falling from down. This is governed by a differential equation. What is a differential equation here? The differential equation is, so the thing which is changing is y, right? And y changes with the time. How does y change with the time? It has a velocity, and the velocity also changes with the time. So it has an acceleration. So it has acceleration and velocity both. So now this differential equation can be written as d square y by dt square is equal to minus g. Why minus g? Because y is in this direction and time or g, it is coming down, is it not? With the time it is coming down, right? So this is time. So what is this the equation? Is this the way in which it will come if I say y and t? Oh, right.
Can you
What
make
will
full
happen? How
screen?
it is coming down? You have to think about it. Initially y will be high, right? It is coming down, y will reduce, correct? Is the way the graph will come is like this, right? Is it this way? You have to think later on. What is
Sir,
the
can
equation of the graph with
hello?
y and t? If you say it is dropping, fine, it's understood. But how does y and t change? That is one thing we have to understand. Somebody is calling. Bharat ji, namaste. Mike, yes, 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 yes. Somebody is talking.
Yeah, can you make it full screen?
Little bit.
Full screen.
It is full screen. It is full screen. No. Yes or no? Bharat, it's not.
Yes, sir. It's in full screen.
Puneet, I don't did not understand what you are saying. You're not getting the full screen there.
No, sir.
Are you using a mobile?
Yes, sir.
Okay, a bit. I don't know. How can I say that? Huh? Mobile
Pin
is not.
search screen on your just pin search screen.
Yeah. So kindly pin my this one, Mister.
Okay, okay.
Got it
Got
now?
it. Yes.
Yes, yes, yes. So here, d square y by dt square is equal to g, right? Now, how will you know this is the acceleration, we know it, right? This is the differential equation, what is taken. There are number of ways in which differential equations are important. For example, this is a falling stone, is it not? This is the falling stone. We put it like this, falling stone or falling object. Now, in case, instead of this, I have a parachute, right? So I have a parachute, and through parachute is coming down. Okay, there's a person here. Okay, and this person is having all the things here. is coming down on a parachute. Now, this parachute is also, the descent of the parachute is also governed by differential equation. What would be the differential equation? What would be the differential equation here? The differential equation is, first of all, there will be acceleration. What is that? This mass is there into velocity, force, okay, which is the force of inertia. So, into dv by dt, change in velocity per time, would be equal to, now if I consider the velocity is in this direction, okay, the velocity is in this direction. Now this would be equal to, I can say, see, the change in velocity is assisted by the gravity. It is stopped by the resistance of the air. Is it not? There is a resistance of air. The resistance of air can be put in V, and the resistance of air is proportional to V square. So you have a differential equation. You integrate this, you find the solution to find out at what time what would be the velocity. Then again you can integrate to find out at what time what is the position. Purpose is that, okay? Or for example, another side, you have, so this is one differential equation. So you see the applications are huge. The applications of differential equations are huge, and you have to find the solution. One of the another example which is used generally in mechanical engineering, okay, is spring, mass and damper, which is the same analogy in electrical engineering, okay, with RC circuit, okay. So there is a lot of places which is used. So there is a mass, there is a spring, and this one is going oscillating. So, and this is why, if I say, this also is governed by a differential equation. What is that? It is my double dash plus ky is equal to 0. There is no damping. You understand? See, actually, we think that engineering is isolated. It is in compartments. Engineering is never in compartments. When you develop a product, all the engineering stream come together to develop a product. That has to be understood. Okay. Nobody can live without a civil engineer, a mechanical engineer, electrical engineer, electronics engineer, computer science engineer. All these engineering is very important. Okay. Yes. So here, this has also analogy on the other side. This is analogous. Analogous in the sense equivalence is there everywhere. And where and all differential equations are used. For example, we call about data science. We say artificial intelligence. Today, everybody is bogged down by artificial intelligence. Why? We get campus elections. What happens after campus selection is different. Okay. So even here, differential equations are used. Chaos is used, market dynamics, there it is used. So there are a lot of things. Okay, students, don't feel bad when I'm seeing this side, because we have students here. Okay, I'm doing online and offline together, so sometimes I see my students who are sitting on this side. Okay, so it's like I'm taking offline and online together. This is how my classes are. Okay, so this is about a differential equation. A number of cases where different predator and prey models are there. A number of things. Okay, now let us understand what is order of differential equation. So what is order of differential equation? Differential equation. When you say order of differential equation means, what does order of differential equation means? The highest order of differentiation present. For example, if I write this one, d square y by dt square minus g, this can be written as d square y by dt square plus g is equal to 0. Here order is 2. Or for example, another one, if you say this one, m dv by dt mg minus bv square, this order is 1. In which variable? V. Okay, so here order is V. For example, here dv m into dv by dt, m into dv by dt, and then you have is equal to mg minus bv square. Order is 1. Makes sense? Order is the highest order of differentiation in the differential equation. Okay. If I have, say, for example, m x double dot means double differentiation with respect to time. Mx double dot plus cx dot plus kx is equal to sine omega t. This is a vibrations equation which is very common. What is the order of this differential equation? Order of differential equation is 2. We have first order differentiation here, but the highest order is 2. So it is the highest order of differentiation. What is it? Highest order of differentiation. Differentiation. Highest order of differentiation is the order of differential equation. Next, degree of differential equation. So I am going a bit faster, okay, and because these things you know, students, generally, right? What is meant by degree of differential equation? Degree of differential equation is the degree or exponent, degree or exponent of the highest order highest order of differentiation in a differential equation. That would be the order of the, sorry, degree of the differential equation. For example, here d square y by dt square plus g is equal to 0. Degree is 1. Make sense? Second thing, if you have, say, for example, the same thing, if I had, say, m, let me write it, m x double dot cube plus cx dot power 4 plus kx to the power 9 is equal to sine square omega t. This degree would be equal to 3. Why? It is the degree or the exponent of the highest order of differentiation. I hope you got the point. Is that clear? So this is the degree or the exponent of the highest order of differentiation. There are other orders of differentiations. There, even though the degree is higher, the order of that is not the highest. Whoever is the, say here, whoever is the elder in the house, his uh, he is being considered as the family head. So family head here is the highest order of differentiation. Make sense? Sure. Have you written this down, students? Okay. Sure. Next. So done. So this is a type of uh, class which is revision. So we are going a bit faster. Next we have linear or non-linear differential equation. Linear. You can stop me at any time, students. You can stop me at any time and ask questions. What do you mean by linear or non-linear differential equation? Let us see some examples one by one. Can you tell me whether this equation sine square x y d square y by dx square plus e power x dy by dt plus e power or say sine of x sine 5x into y is equal to log of root x. Okay, this one. Is this a linear differential equation or non-linear differential? It's a linear differential equation. equation. Very good. This is linear differential equation. Let us see this. dy d square y
Sir,
yes please.
one, just like how is it again that linear, sir?
I'll tell you. I'll tell you in a moment. Okay. So you understand that. He has said he knows it. That's why he said linear. I will tell you in a moment. Okay. Now, d square y by dt square plus y square is equal to sine y. Is this linear or non-linear? Others, is it linear or non-linear? Or let us say is equal to 5 now. Linear or non-linear? Yes. Bharat, tell me fast. Bharat, you have to speak up, man.
Non-linear, sir.
Non-linear, very much. So this one is non-linear. Now, what is that which is there here? Why did I say this simple one as non-linear, but this being very complicated, I say it is linear? What is the reason for that? Is, see, in any equation, there is dependent variable. So let us say this is one, equation one. Let us say this is equation two. There is a dependent variable, and then there is independent variable. So there is dependent variable and independent variable. If you consider dependent variable, in one, dependent variable is y, independent variable is x. In equation 2, dependent variable is y, independent variable is t. Make sense? So now, if the dependent variable dependent variable variable differentiations differentiations and the variable degree is not unity, then differential equation is non-linear. Now what is happening? The variable here is y square, dependent variable is y, and there you have a square. It is not unity. Even if it is square root, if I had 1 by 2, then also it is non-linear. Okay, if it is not 1, it is non-linear. First case. Second case, okay, if the dependent variable, if the dependent variable, if the dependent variable and if the dependent variable and its derivatives, its derivatives appear in a product, appear as product in a term, then non-linear, then it is non-linear. Nothing the on the independent variable. Independent variable, nobody is there to control that. Whatever it says, it's okay. Make sense? Fine. So non-linear and linear is seen like this. There are questions in GATE only based on this. Only based on this, there are questions. Okay. Sure. Slow and steady wins the race. You have to, the things has to percolate. Okay. Done. Okay. Done. Written. Okay. Take time. Take time. Go for it. Third option is that this is one, two. The third reason. There is third reason why a equation, differential equation, can be non-linear. Because GATE, this question has appeared. I'm not going to do questions now. Okay, but you can see the questions in GATE. After you do this, you can answer this question. Okay. Now, done. Online students done writing. Hello, Bharat, you're writing.
Done, sir.
Done. Very good. Okay. Yeah. So fine. Others done? Agastya? Anandu? Done, no? You can talk directly, okay? Don't worry. Okay. Now, third one. Third one. Yes, very good. Okay. Third one would be if the dependent variable, dependent, nothing on independent, dependent variable appears as a transcendental function. This transcendental has nothing to do with any meditation. Okay. So transcendental function. What is transcendental function? The function that meditates, right? It has a lot of other things in that, right? So what are those? Sin x, cos x, e power x, tan x, log x, all these things. Actually, sin x can be expanded in a different way, is it not? It is not one unit. So if you say sin x can be represented as, say, what is sin x? What's the expansion of sin x? Come on. Bharatji, tell me what is the expansion of sin x fast. ನಿನ್ನೆ ಹೇಳಿದೆ sin x is expansion ಏನು? sin x is expansion ಎಂತದು? ಹೇಳಿ ಬೇಗ. x minus x cube divided by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial. So ಇದು ಸಮುದ್ರ ಮತನ ನೆನಪಲ್ಲಿ. Okay, sin has made a lot of sense, so it is at odds. Okay, and also sine function is growing. When a person grows, he faces a lot of odds. Correct? When sine grows, he faces a lot of odds. That is why it has all the odds there. 1, 3, 5, 7, all are odds. Is it not? What about cos? Cos x. Cos x ಹೇಳಿ, ಭರತ್ ಹೇಳಿ. ಯಾರು ಹೇಳ್ಬೋದು ಕಾಸ್ ಇದು ಹೇಳಿ. What is the expansion of cos? One minus. It is falling, Papa. Observe that it is falling. Cos is falling, is it not? When cos is falling, there is no odds. It's all being evened out. When cos is falling, everything is evened out. So when it is evened out, what happens? It goes down. Is it not? Okay. And then 1 minus next x square by 2 factorial plus x cube by 3 factorial. Correct? No, x power 4 by 4 factorial. Very good. 4 factorial. So it's all even. Okay. Fine. What is e power x? E power x ಹೇಳಿ ಯಾರಾದರೂ ನೆನಪಲ್ಲಿರ್ಬೇಕಿದೆಲ್ಲ. e power x ಏನು? ನಾನು ಹೇಳಲ್ಲ. e power 0 ಎಷ್ಟು? 1. ಮತ್ತೆ ಪ್ಲಸ್ x ಇದೆಯಾ? ಕರೆಕ್ಟಾ? ಪ್ಲಸ್ ನಂಗೆ ಗೊತ್ತಿಲ್ಲ, ನನ್ಗೆ ಮರ್ತೋಗ್ತಾ ಇದೆ. x square by 2 factorial. ಕರೆಕ್ಟಾ ತಪ್ಪಾ? ತಪ್ಪ ಕರೆಕ್ಟಾ? ಬೇಗ ಹೇಳಿ.
ಕರೆಕ್ಟ್ ಸರ್.
ವೆರಿ ಗುಡ್.
ಸ್ಕ್ವೇರ್
ಇಲ್ವಾ? x cube by 3 factorial minus ಉಂಟಾ ಇಲ್ಲಿ? ಹೆಲೋ ಹೇಳಿ ಬೇಗ ಹೇಳಿ. ಇಲ್ವಲ್ಲ? ಸರಿ, ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಸರಿ. ಸೊ ಈ ತರ. ಓಕೆ, ಆಯ್ತು, ಇದು ಆಯ್ತು. ಈಗ ಎಕ್ಸಾಂಪಲ್ ಕೊಡ ಒಂದೊಂದು. ಈ ತರ ಇದ್ರೆ It is non-linear differential equations. ಸರಿಯಾ? ಎಕ್ಸಾಂಪಲ್ ನಾನು ಇದು ಕೊಡ್ತೇನೆ, ನೀವು ಹೇಳ್ಬೇಕು ಸರಿಯಾ ಇಲ್ಲ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು, ಆಯ್ತಾ? ಸೇ e ಪವರ್ x dy by dx plus d square y by dx square into y dy by dx plus e power or we can say sine x square y is equal to cos of log x. ಹೇಳಿ ಲೀನಿಯರ್ ನಾನ್ ಲೀನಿಯರ್? ಹೇಳಿ ಬೇಗ ಎಲ್ಲರೂ ಹೇಳಿ, ಲೀನಿಯರ್ ನಾನ್ ಲೀನಿಯರ್? ಪರತ್ ಹೇಳಿಯಪ್ಪ, ಲೀನಿಯರ್ ನಾನ್ ಲೀನಿಯರ್? ಅಗತ್ಯ ಮಾತಾಡ್ಬೇಕು.
ನಾನ್ ಲೀನಿಯರ್.
ನಾನ್ ಲೀನಿಯರ್ ಎಲ್ಲರೂ ಅಗ್ರಿ ಮಾಡ್ತಾ ಇದ್ ನಾನ್ ಲೀನಿಯರ್ ಅಂತ? ಎಸ್. ಹೂ ಡಸ್ ನಾಟ್ ಅಗ್ರಿ ಇಟ್ ಇಸ್ ನಾನ್ ಲೀನಿಯರ್? Yeah, is it non-linear? Puneet, linear or non-linear?
The linear.
Linear. Okay. Non-linear ಇದ್ದವ್ರು ಹೇಳ್ಬೇಕು ಯಾವ್ದು ಟರ್ಮ್ non-linear ಅಂತ ಹೇಳ್ಬೇಕು, ಆಯ್ತಾ? It is non-linear. In fact, yes. It is not. No, it is non-linear. It is not linear. Why? This term is linear or non-linear? Linear. Very good. Why? E power x is there. Here it is d square y by dx square. It is linear term. E term entadu linear non-linear? Linear or non-linear? Sin x square into y. It is linear term. What about this? This is also linear, but this one is the non-linear term. Okay, there is one dependent function multiplied by its derivative. So when a yeah, here I hope everybody understands Kannada. So if I speak to Kannada, it's okay. Yeah, Puneet, tell me.
Absolutely, yes, sir.
Yes.
Yes, sir.
So Anandu, you know Kannada? Everybody knows Kannada, I
Ah,
suppose.
okay.
Yes or no?
Yes, sir.
Yes. Okay. So sometimes I use Kannada in between. So if in case you don't understand anybody, you can tell me, okay, that you don't understand Kannada. Okay. So that is non-linear, right? Another one. Let us say sine, or we'll say root of dy by dx, okay, plus 2y is equal to sine x. Linear or non-linear? Non-linear. Very good. ಯಾವ್ದು non-linear term? This is the non-linear term. Clear? ಏನೋ ಡೌಟ್ ಇದೆಯಾ? ಕೇಳಿ. Is there any doubts? Please ask me. No doubts, right? So let us go further. This kind of questions, a lot of questions are there in GATE. Just a revision. This is a revision, so we are not doing everything. We are doing every topic one by one. Fine. So, correct? Yeah. Next one. Next thing is that what do you mean by solution? Concept of solution. Concept of solution. What do you mean by solution of differential equation? What is meant by solution? Let us take an example and let us solve. Okay. So, let us say, okay, let us say that see, I will say given given that okay, say for example dy by dx, right? Dy by dx, or you will write, okay, x dy by dx minus 2y is equal to 0 is a differential equation, right? And the solution for this differential equation, for this differential equation is y is equal to x square. What does that mean? It means that if I substitute, if I differentiate this, what this differentiation would be? This would be dy by dx is equal to 2x. Fine. Dy by dx is equal to 2x, right? Now we will substitute here. So if I substitute in the equation, substituting in the equation, what do we get? Instead of x, there is x into dy by dx. Instead of dy by dx, I'll substitute 2x. Then minus 2 times y. What is y? We have taken x square, is it not? X square. What this would be? This would be 2x square minus 2x square, which is equal to 0, which satisfies this equation. So if a differential equation is a solution, or if this is a differential equation and this is the solution, means when you substitute back, you will get the differential equation is satisfied. That is what is meant by solution of a differential equation. Make sense? Next. Now, there are two types of solutions. One solution is called uh, explicit solution. Another one is called implicit solution. All those things we will see it a bit later. Okay. Now, for example, okay. For example, let us look at it. Okay. Okay. See here, this solution for this only. Okay. Uh, For example, let us say another example. This is explicit. See, y is equal to x square. It's explicit. Y is on one side, x is on other side. Now let us say another example where if I say y dy by dx plus x is equal to 0 is a differential equation. This is the differential equation. Now for this, solution of this differential equation is x square plus y square plus minus 1 is equal to 0. Can you separate x on one side and y on other side? You cannot. You have to say y is equal to x is equal to, you have to write x square is equal to, now if you understand here, you have to write 1 minus y square. Okay. Now this here, you see, both equations are into it. So this is inside it. It is not one here, the other there. Both sides of the equation. Now the same thing I can do. X is equal to square root of 1 minus y square, or y is equal to square root of 1 minus x square. These are implicit. This is explicit. I'm sorry. This is explicit solution. Whereas this is implicit. These are implicit solutions. Same solution explicitly you can do, sometimes you have to do implicitly, or not all implicit solutions can be explicitly defined. Okay, this is what it is. Okay. Now let us understand another equation. Concept of solution is not done. Let us understand this is the first thing about concept of solution. Slowly we will go further. Done. Now so, next question. For example, let us say another example of dy by dt or dy by dx is equal to, say, sin x, or dy by dx minus sin x is equal to 0. Now can we solve this differential equation? Of course we can, is it not? We can write dy by dx is equal to sin x, and you can integrate it. When you integrate, you find the solutions, is it not? So integrating, when you integrate, what do you get? You get y is equal to sin x, you have to integrate, is it not? So it will be integration of sin x dx plus a constant, correct? So what is integration of sin x? Minus cos x. So you will get minus cos x plus a constant. Now this way, when I put it, it is called the general solution. This is called the general solution. Why it is called a general solution? It is called the general solution because it is cos x minus cos x. Fine. Minus cos x means cos x starts from here. Minus cos x starts from minus 1. If it was 0, if c was 0, it would start from here, right? This would be pi by 2. This would be, say, 2 pi. Sorry, this would be pi. This would be 3 pi by 2. This would be 2 pi, like this. So this would go like this, and then it would go to the top, right? Then it would go down like this, then it would go here. This is one solution. Another solution may start from here, it may go till here, then it may go down like this, right? So, and then it may come down this way and this way. This might be another solution. So like this, I'll have a number of solutions. So it is a general trend, it says. Observe. It says only the general trend. It does not specify the proper curve. The proper curve you have to specify if you give a initial conditions. Say if I define the initial conditions or boundary conditions. Okay, I will call it boundary conditions. If I say boundary condition that at x is equal to 0, y is equal to minus 1. At x is equal to 0, y is equal to minus 1. Then I can say what is c. So here if I put like this, then what happens? Y is equal to minus 1 is equal to minus cos 0 plus c. Minus cos 0 is 1. That means c is equal to 0. This c is equal to 0 is about this curve. Make sense? C is equal to 0 is this curve. This corresponds to this particular solution. Observe. This corresponds to this particular solution. If I have the boundary condition that at x is equal to 0, y is equal to 0, if I put like that, then what will happen? 0 is equal to minus cos 0 plus c. That means my c is equal to minus 1 or c is equal to plus 1, right? So that is about this particular solution. Makes sense? It starts from here and then goes. Fine. So this is the particular solution. You understand? When you put the boundary conditions, what you get? You get this as the solution for this would be, the particular solution would be y is equal to cos x. For this, it would be y is equal to cos x plus 1 or anything. This is particular solution. This one is the particular solution. Make sense? Hello. So general solution, when you put the boundary conditions, you get particular solution. Correct? Clear? Any doubts? Understand that it percolates? Very simple, very simple. Okay, nothing great, I know that. I know that you people know this. Is it not? But it's about detailing. It's about details. So it's very important that you understand this. Details are very important. Then now the question is, when I say dy by dx is equal to sine x, what does that mean actually? What are we giving in a differential equations? What are we saying by saying dy by dx is equal to sine x? What do we put there? What is the actual meaning of that? Let us see that. Okay. Meaning of a differential equation. I hope everybody has written this down. Fine. Okay. What do you mean by what is differential equation? For example, if I say dy by dx is equal to sine x, what is meant by this? That means that I have the thing like this. Okay, I have this here. Okay, at every point, I am defining if this is y and if this is x. What I am defining is I am defining the slope. So at x is equal to 0, at x is equal to 0, sine x is equal to 0. That means at this point, the slope is 0. I'm just putting a dash here. I will use another this one. So what I'm doing actually, I'll put a yellow dash or I'll put a brown dash. So actually I am actually doing, I'm putting a line here. That's it. So whatever the solution passes like this. Okay. And that is what is happening here. Observe. The one which is here passes through a dash. The slope is 0. Here you see slope is 0. I've not done it properly. Okay. Its slope is 0. That's what the meaning of this. Or for example, at x is equal to, I'll use the other this one. Okay. So if I say at x is equal to pi by 2, what is the slope? Sine pi by 2 is how much? 1. Sine pi by 2 is 1 means 45-degree angle. So at x is equal to pi by 2, x is equal to pi by 2 here, we are not talking about y at all. Okay, at x is equal to pi by 2. Here, when you say, see, it does not depend on dy by dx, is not dependent on y at all. It is only dependent on x. So whichever y are there, observe, at whichever y you take, it's all this slope. Make sense? This is a slope at any y. If you consider at any pi by 2, the slope is always like this, 45-degree slope. If you consider at x is equal to pi, what is sine pi? 0. So at pi, if you say, the slope is all 0. In between, you have all the intermediate values. If I say 3 pi by 2 pi by, sorry, what is it? 3 pi by 4. What is the answer? What's the value? -1. Right? So at x is equal to 3 pi by 2. I'm sorry, not 3 pi by 4, 3 pi by 2. What's the answer? Sine 3 pi by 2 is equal to -1. So what are the slopes here? Slopes are all negative. Wherever you put, it will be negative slope. The meaning of the differential equation is that. It's not just the first slope. When you say the second order, you're talking about second slope also. That is slope of the slope. I have to put another curve defining slope of the slope. So what does differential equation do? It puts a lot of information in a small space. In one equation, you say a lot. You have a small equation. In that, if you say a number of things, that becomes a differential equation. From one differential equation, you can take a lot of value, lot of information. So this dy by dx has the information about the slopes, and when you solve it, it has the information of the curves. The curves what you get in terms of y and x is the solution, and the solution is inherent. And how many solutions are there? Infinite amount of solutions. Make sense? Now we'll see another example. Have you written this down, students? So meaning of solution is very, very, very important. Okay. Sure. What happens generally is students equation kottidare, you give the equation, sir, get the answer. Why it is done, how it is done, that is not understood. And if you understand this, there's no forgetting, is it not? There's no forgetting. Then, okay, next one. Once that is done, next thing, let us see another equation, we'll solve it. The simple equation what we have done till now, which is falling stone, right? So falling stone, when you say d square y by dt square is equal to, what is that? D square y by dt square is equal to minus g. It's falling due to gravity, right? So you have dy integrate this. Let us integrate. When you integrate, what do you get? You get dy by dt is equal to minus gt plus a constant. Let us write the c1. Then again integrate again. Integrate again. What do we get? We get y is equal to minus gt square by 2 plus c1 t plus c2. Now this has a lot of things here. Now what about this? What is this? This is the slope of the slope. Slope of the y versus t graph. And this is the slope of the y versus t graph. So what happens as t increases, if you consider, if I say this is the y, this is t, if I say, how is the slope going? It changes with the t. And how it is? Negative t. So initially when t is equal to 0, what is the slope? Initially constant is important. You have to add a constant. Suppose the constant is 0. It means I am leaving it with the 0 velocity. Observe. What does that mean? Here, this relates to velocity. Now when C1 is equal to 0, it means I am releasing with 0 velocity. That is t is equal to 0, velocity is 0. Makes sense? I am releasing with 0 velocity. If I release with 0 velocity, because first is constant. If it is not there, then it's different. Okay. So if I'm releasing with 0 velocity, then what will happen? Initially, what is dy by dt? It is minus g into t. G into t is 0. So what is the slope here at this? It's 0 slope, is it not? Wherever it is 0 slope at t is equal to 0. As t goes on increasing, what will happen? The slope changes to negative slope. So what will happen as t increases? This will have a bit negative slope. This will have more negative slopes. And when it goes to infinity, it will have almost like this. Correct? So if I start from here, I have to follow what is the next curve. What's the next curve? Next curve, next curve. This is the y versus t curve, is it not? And this is really, really big. Makes sense? That's how you write you can see it and write. But that's what we get here also. What do we get here? A parabola. ಯಾವುದು? ಕೆಳಗೇನೆ ಬರಬೇಕು. ಯಾಕೆ? ಸಾರಿ 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 ಕೆಳಗೆ ಬರುವುದಿಲ್ಲ. ಐ ಆಮ್ ಸಾರಿ. ಯಾಕೆ ಕೆಳಗೆ ಬರುವುದಿಲ್ಲ? ಕೆಳಗೆ ಬರ್ತದೆ ಆಕ್ಚುಲಿ. ಯಾಕೆ ಕೆಳಗೆ ಬರ್ತದೆ? ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ಮೈನಸ್ ಇದೆ. y ಮೈನಸ್ ಆಗ್ತಾ ಇದೆ ಅಲ್ವಾ? y ಮೇಲೆ ಇದೆ ನೋಡಿ. ಅಬ್ಸರ್ವ್, ಇಲ್ಲಿ ಮೈನಸ್ ಯಾಕೆ ಹಾಕಿದ್ದೇನೆ ಅಂತ ಹೇಳಿದ್ರೆ y ಇಲ್ಲಿದೆ ಆಯ್ತಾ. ದಿಸ್ ಇಸ್ y. ಫ್ರಮ್ ಸಮ್ವೇರ್ ಟಾಪ್ ಇಟ್ ಇಸ್ ಫಾಲಿಂಗ್. ಸೊ ವಿತ್ ದ ಟೈಮ್ it comes down and then it falls. ಜಾಸ್ತಿ ಯಾಕೆ? ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್. what is this one? This is y dy by dt, ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್. ಅರ್ಥ ಆಯ್ತಾ? ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್ ತಾನೆ y ಮತ್ತು t ಅಲ್ಲಿ. ಮೈನಸ್ gt ಇದೆ. ಕ್ಲಿಯರ್ ಆಗ್ತಾ ಇದೆಯಾ? ಸೊ ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್ ಇದ್ದಕ್ಕೆ ಆಂಗಲ್ ಹೀಗೆ. ಕ್ಲಿಯರ್? ಟಿ ಜಾಸ್ತಿ ಆದಾಗೆ ಸ್ಲೋಪ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇರುತ್ತಲ್ಲ. ಇಲ್ಲಿ ಟೈಮ್ ಜಾಸ್ತಿ ಆದಾಗೆ when t is going on increasing, this becomes more and more negative, is it not? Yes or no? So that's why it happens like this. I hope it's clear, students. And this is a parabola. Yes, this is a parabola. That's a solution. There might be a lot of parabola. You may start from here. You may start from here. You may start from here. Make sense? So dependent on all the things, curves, you get this. Correct? Getting it, students? It may not come like this. I'm sorry. It's not always. You don't think that it goes straight like this. It may cut and fall in this fashion also. It may fall in this fashion. Possible. ತುಂಬಾ ದೂರ ಹೋದ್ರೆ ಮಾತ್ರ ಇದು ಹೀಗೆ ಬೀಳುತ್ತೆ. You understand? You okay? That is not about falling. It's about falling from the top. Okay, but this is also applicable for parabolic flight. If it is a parabolic flight, you should not only do this. What you do, a stone throwing, and there is a parabolic flight which is there, or a ballistics, for example. Even there, you have to write. You have to solve d square y by dt square is equal to minus g, and d square x by dt square is equal to 0. You solve this simultaneously, you can define the parabolic flight of a stone which is thrown, or a ballistic. You put a billet, so it will go as a parabolic path. Make sense? Sure. Done? No, any doubts here, students? Done, no? Now, with this being done, let us go with variable separable equation. Solution of differential equation by variable separation. Solution of a differential equation by variable separation. Let us look at this. See, generally separable equations can be written in the form g of y dash is equal to f of x, where y dash is equal to dy by dx. Now once you get that, what you have to do, you have to write g of y dy by dx is equal to f of x, which gives us g of y. Okay, g of y into dy is equal to f of x into dx, and you integrate that. You integrate g of y dy is equal to integration of f of x dx, plus you get a constant. This would be the solution. Make sense? This would be the solution of the differential equation. Then it is a variable separator. Let us see some examples which has come in gate only directly. Okay, some examples. Okay, and this is one of the most common topic that comes in gate. So let us look at it. So here I don't know which year it has, which branch it has come. It's a general list I have. So any branch it may be. Okay, it may be mechanical, civil, electrical, electronics, computer science, anything. Okay, so we will do one example. Okay, one example is, should we do a practical example? Yes, we will do a practical example which has come in, say 2004. I do not know which gate it is. 2004. Okay, 2004. It has come for 2 marks. Let us look at it. Biotransformation. Write it along with me, students. Biotransformation of an organic compound, of an organic compound. Biotransformation of an organic compound having concentration. See where and all it is used. Having concentration X can be modeled using an ordinary differential equation dy by dx by dt plus kx square is equal to 0, where k is the reaction rate, If x equals a at t is equal to 0, if x is equal to a at t is equal to 0, the solution of the equation is, a x is equal to a into e power minus kt, b 1 by x is equal to 1 by a plus kt, c x is equal to a into 1 minus e power minus kt, and d is x is equal to a plus kt. What is the answer? We will do this. Okay, so solution is something like this. Solution is, you have dx by dt, I will put it on the other way around, minus kx square. Now this is separable. I can write this as dx by x square is equal to minus of k into dt. Now let us integrate. Now when you integrate dx by x square, what do you get here? You get minus 1 by x, correct? Agreed? Why minus 1 by x? You have x raised to minus 2. When you integrate, you have to add, right? So it is, when you integrate dx x square minus 2. Just a second. Hello? Hello? Hello, Haley? Hello, Haley? Haley? Hello? Who's this? ಯಾರು ಮ್ಯಾಮ್? ಯಾರು ಮಾತಾಡ್ತಾ ಇರೋದು? ಹಾ, ನಾನು ಕೊಡ್ತೇನೆ. ಅಲ್ಲಿ ಕೆಳಗಡೆ ಉಂಟಲ್ಲ, ಇದರಲ್ಲಿ ಕೆಳಗಡೆನೆ ವೆಬ್ಸೈಟ್ ಉಂಟು. ಲೆಟ್ರೆಡ್ ಅಲ್ಲಿ ಕೆಳಗಡೆ ಇಲ್ವಾ? apexacademics.co.in, academics.co.in. Okay, academics.co.in. Okay, so x square dx, integration of x square dx is the thing, is it not? So now once that is done, okay, integration of x square dx is nothing but equal to minus 1, so 2 plus 1, and x raised to minus 2 plus 1, right? So it is minus 1 and x raised to minus 1. So that's what we have written, minus 1 by x is equal to minus k dt, you will get t, correct, plus a constant. So this is a solution, right? How to find out the constant? You have given x is equal to a at t is equal to 0, correct? So substitute that. So what you will get here, you can write this as minus 1 by a is equal to minus k into 0 plus a constant. And that constant is will be actually equal to how much it will be? It will be 1 by, here c can be anything, minus can be put anywhere. So it's everywhere minus. So I'll put it as minus c instead of having plus c. I can do that also, right? So you'll have c is equal to 1 by a, right? So what is the equation? The equation is the solution of the equation. I can write this as equal to, okay, this whole thing I can write it as 1 by x is equal to, I'll write it all minus, I will take it out because minus can be taken out everywhere. So 1 by x is equal to kt plus 1 by a, correct? What is the answer? B. Easy. Should not get intimidated, that's it. Yeah. Easy. Done. Next. Another point here. Okay. Uh, Once that is done, this is another question which has come in 2005. Okay. Let us do that. The following differential equation, the following differential equation has, okay, the differential equation is 3 into d square y by dt square plus 4 dy by dt the whole cube plus y square plus 2 is equal to x. A, degree is equal to 2, order is equal to 1. B, degree is equal to 1, order is equal to 2. Third one, or C, degree is equal to 4 and order is equal to 3, and D, degree is equal to 2 and order is equal to 3. What's the answer? Tell it first. What's the order and degree? This is 1 mark question in GATE 2005. Recently also these kind of questions have come. So GATE is in fact easy in this fashion. You have to understand all the easy questions. There are at least 30 questions which are on this easy level, like this. You know the basics, you can answer. Yes, answer, students. What's the answer? Fast. Come on. What is the degree? Order. Correct. That's it. Degree 1, order 2. Simple. Because degree 1, because the highest order has only 1 degree. Order 2, because it's of the second order. That's it. Easy. Next. Let us see some more variable separable equations. Okay. This is just like that. I got into that. So I tried to do that. Okay. So here, next one. This has come in 2005 again for 1 mark. I want you to rush and answer this. Okay. The solution of the first order differential equation, x dash of t, x dash of t, oh sorry, x dash of t is equal to minus 3 times x of t, or x of 0 is equal to x naught is, do it fast and tell me the answers to it. A, x of t is equal to x naught is equal to x naught into e power minus 3t. Okay. B, x of t is equal to x naught into e power minus 3. Okay. And then C would be x of t is equal to x naught into e power minus 1 by 3t. Let this be 3t only, minus 3t. Okay, minus 3. Okay, let it be. Okay. 1 by 3. Okay, minus 1 by 3 only, not 3t there. Okay, so x naught is equal to minus 1 by 3t. I'll write it here. I will just change it a bit. Okay, and then x of t is equal to x naught into e power minus t. What's the answer? Let us look at it. How do you do that? You get solution. Very simple. Next we will go with these kind of questions are a lot. So just you have to separate out the equations, right? So let us see. So we have dx by dt is equal to minus 3x. So you just have to do dx by x is equal to minus t. So what is this? Dx by x is equal to minus t. Integrate. So when you integrate, you get, what do you get here? When you integrate this, you get log of x. 1 by x, when you integrate, you get log of x, right? Is equal to minus t, right? Minus, sorry, this is dt. I'm very sorry, students. Dt here. So minus t plus a constant, right? This taking exponent on both sides, taking exponent on both sides. What do we get when I take exponent on both sides? You get e power log x is equal to e power minus t plus c, correct? Excuse me. E power log x is x is equal to, here what you get, c. What do you get? E power minus t, e power plus c. We will call this as at. So this is the equation. This is the general equation. This is a general solution. 3 ಇದೆ ಅಲ್ಲ, I'm sorry, 3 dt. So here 3 ಇದೆ. So ಇಲ್ಲಿ you get 3t minus 3t. I'm very sorry, I missed that minus 3t plus a constant, right? Minus 3t plus a constant. This is the general solution. Particular solution you get by knowing the constant here, right? What is a constant? At x is equal to 0, at t is equal to 0, x is equal to, at t is equal to 0, x is equal to, how much is that? X is equal to x naught. So you can write x naught is equal to e power minus 3 into 0 plus into e power c, which gives me e power c is equal to x naught, right? So e power c ideo ಅಲ್ಲಿ x naught ಬರ್ದ್ರೆ ಆಯ್ತು. So what is the answer you get? X is equal to x naught into e power minus 3t, correct? This is the answer. So the answer is A. Done? Easy? Do you need more examples or did you understand? Easy then, Sulabha then. It's very, very easy. This is the only thing which is there, which was there. And maximum questions till now, whatever appeared, around 40% of the question has come in variable separate. Very, very easy ones. Okay. Sure. So you should not miss this in GATE. People who are preparing final some days in GATE, this is the best thing to do. This is what you have to prepare for, right? So this end moment things will be very helpful. Well, let us go next. Next we will go with exact and inexact differential. Let us see that. Okay. Any doubts till now, students? Online students, any doubt here? No, right? Okay. Next. People have reduced. Okay. Sure. Yes. Next one. Next thing is we'll go with exact and inexact differential. Very, very important. Exact and inexact differential. Yashoda, you are right. It is only for civil and mech generally, but differential equation is applicable everywhere. So it is not specific to any. It is not specific to any branch. Okay, this differential equations, calculus, Laplace transforms, maths for all subjects same. Okay, because this is part of all engineering, and what I do is I solve problems from all the engineering. This one I don't know from which engineering branch these questions are there. Not important. When you go to higher level, you will realize that there is no difference between branches. Okay, people think only here, sir, namge campus selection agate avriki campus selection agala. So our question is only campus selection. If you understand the amount of mechanical students who get, I was explaining that to the other guy now. Okay, 270 vacancy for ONGC, more than 300 vacancy for NTPC. What is their pay package? 24 lakh per annum. If you get 24 lakh in Microsoft, if you don't do well, they will give you the pink slip. Here, if somebody has to give the pink slip, he cannot go. He has to go by Government of India rules. And if he wants to put you out, he has to give so much of reasons that he should keep all his work aside and he should work only to put you out. So that is the usefulness of mechanical, civil, electrical, electronics. Getting a job is difficult. I do agree. But once you get a good job, nobody can push you out of it. That is that. The security which comes with mechanical and civil and electronics and this one. Even core computer science, if you go to some of the research areas, then you have things. But not on the software companies, this mass recruiters. Your salary goes up like anything within few years. Mechanical, it does not go like that. Okay, exact and inexact differentials. Civil also till around 30 years they struggle, but after that they are the king. Is it? Is it not? Which civil engineers is what do you say? Who is talented is without job. He gets something or the other. Even a diploma person does crores of rupees. An engineer can do extreme money. Chalo. Exact and inexact differential. So yes. So let us look at it. Okay. So when you say exact differential, now let us understand this first. It's a bit involved, okay, and very important. Okay, very important in the sense in engineering it is of high importance. Okay, let us look. Tomorrow we are going with second order linear differential equation. Okay, so second order linear differential equations will be next. Yes. Now, generally, when you take a differential, for example, if you say a function u is a function of x comma y, say, or x comma y comma z comma t, let us say. Now, here you can differentiate. For example, if you want to write du by dy, it is not common. You cannot write du by dy just like that. How do you find out du by dy? U is a function of u is a function of x, y, z, t, everything. So how do you find out du by dy? You write du by dy as dou u by dou x partial into dx by dy plus du dou u by dou y into dy by dy plus dou u by dou z into dz by dy plus dou u by dou t into dt by dy. I specifically took y instead of t. People take t generally. Okay. So now what happens? You don't worry about what it is. Okay. So what is this? You get dou u by dou x into dx by dy plus dou u by dou y. This dy dy cancels, and then dou u by dou z into dz by dy plus dou u by dou t into dt by dt. This is the general case. Now if I have a function, say f is equal to a function of x and y alone, and now I don't want this. See here dy, if I cancel dy here or in this only, if I take out dy, I can write du as equal to dou u by dou x into dx plus dou u by dou y into dy plus dou u by dou z into dz plus dou u by dou t into dt. This is called a differential. This is called a differential. Before going to exact and inexact differential, we have to understand what is meant by differential. This is meant by differential. So now let us say with the two dimensions only, because generally when you put graph, we put graph in two dimensions, is it not? So let us put it in two dimensions. So when we put in two dimensions, I can write, say f is a function of x comma y. This is very important thermodynamics. When you consider exact differential, inexact differential, where is it, it is used? Exact is properties, inexact is path functions like work and heat. So there it is used. So when you say inexact, it is about path functions, and when you consider exact, it is about point functions. Okay. So now if I have to write df, what is df? Df is nothing but dou f by dou x into dx plus dou f by dou y into dy. Make sense? So this you write it as equation 1. Write it till now. Write this as equation 1. I'm going a bit faster, I know that, but I think you're okay with it, is it not? Done? Now here we can write this function with respect to x is also a function of x and y. So I can write this, I will write it as m of x comma y, and this one only I will write it as n of x comma y. So the differential I will write it as df, or I can write, if it is a constant, if df is equal to constant, df is equal to constant would be along the line where f is equal to constant. When f is equal to constant line, for example, if I say, okay, I'll write it in the next slide. Okay, write it in the next slide. Okay. So let us say, like you have stream function, like you have velocity potential functions, like you have isobars, you may have what you say, you may have isothermal lines, is it not? Say this is one line where f is equal to constant. Fine. Along this line, okay, what happens? Df is equal to 0. Along this line, what happens? Df is equal to 0. Df changes when you go from this point to this point, is it not? But along this line, it is 0, right? So, along a constant, along a constant f line, df is equal to 0. So we can write df is equal to dou f by dou x dx plus dou f by dou y dy is equal to 0. I will write this as m of x comma y dx plus n of x comma y dy. ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಆ ಲೈನ್ ಅಲ್ಲಿ ಹೋಗುವಾಗ when you go along that line there is no change. df means change, is it not? When you consider a stream function, when you say uniform flow, in a uniform flow, this is the stream function psi. This is psi 1, this is psi 2, this is psi 3, and so on, right? So when you go along this line, there is no change in psi. So along the constant f curve, it is equal to 0. Is it not? Now this one, if along a constant line, if this is 0, now what I can do is, okay, okay, we can say if that is the case, then f is equal to constant, is it not? Along the line, f is equal to constant, right? Along f is equal to constant line, correct? No. So now, if I say here, what happens? Dou f by dou x is equal to m, dou f by dou y is equal to n. Now, what is dou m by dou y? Dou m by dou y would be equal to dou f, dou y, dou x, correct? And dou n by dou x would be equal to this is dou square f, dou x, dou y. Now, if these both are equal, then it is called the exact differential. If these both are equal, those are called exact differential. If those both are not 0, then it is called inexact differential. If, I'll write this here, if dou m by dou y is equal to dou n by dou x, then f or df is a exact differential. Exact differential. Else, now generally what has happened is when we derived starting out from a function which is defined at every point. Now this is very subtle, understand. We have started with a function that is defined at every point. So if a function can be defined at a point, then it is exact. Now, just because I can write something like m of xy dx, n of xy dy, that doesn't mean this represents a function. If it represents a function which is part of point, function xy, then that exists and that's an exact function, exact differential. Now there are functions which is not dependent on the position. For example, length of a curve. Is length of a curve dependent on a position? What would be the length of curve at this point? Can I say that? You cannot say. You have to say from this point to this point. Then not just saying that, it has to be not just going from this point to this point. It's also, it's not just going from this point to this point. It also means how you are going. That's also important. So path is important there. It's not just the end point that is important. It is the way you are going is also important. So those are path differential or path functions, and those are inexact. So path exact differentials are point functions. Write this one. Are point functions. This is how we start with thermodynamics, is it not? Thermodynamics, when we started with exact and different inexact. You remember that? Now let us see the solution. How to solve this? Exactly, work and heat. Work and heat are path functions. They're not point functions, is it not? So see the amount of things which are there. And the person who does thermodynamics, they are used in a lot of things. Thermodynamics is much deeper. And there is something called statistical thermodynamics, which is so good, so strong, that if you have the depth of it, sky is the limit. That is why these companies only come to IITs, not for BTechs, for MTechs. BTechs generally go to bank jobs only. Consultants. They go to bank jobs. They don't do engineering. Engineering is done by MTech students. And if they do engineering, they do outside India. They will never contribute to India's economy. They contribute only to US and European economy. The people who contribute to Indian economy are the people who do GATE and do engineering, MTech in IITs and this one. Most of the ISRO, DRDO are our people only. Huh? Yeah. CAs also, of course, sir. So when CA is there, how can I say no? CAs never go to outside India, you know. So Nagbhushan sir has told that it is CAs also, and it is true. A CAs never go to foreign countries. Is it so? True? Yes, no? They stay here only. No, they go, it seems. So then they are helping other economy also. They want to go, they'll go, obviously. Now, next one. Now let us see how to get the solution. Okay. So what is the equation? Mdx plus ndy is equal to 0. How to find the this one? So now, generally, what do we do is we guess it basically. Okay. For example, we say, for example, if I have, see, what is m? M is equal to d f by dx. M is df by dx, is it not? Sorry, no, dou f by dou x. I'm very sorry. Have I used dou or have I used d? I've used dou, I suppose, correct? It is dou only, right? So it is dou f by dou x, partial differentiation. So what do you write? You can write f when you integrate this. You can write f as m dx integration. So we are integrating with only with respect to x, but then you have y also there. So what y we are considering is a constant. So you can have f of y remaining plus maybe a constant. which we are not worried. Later on we can add it up, right? Then if I consider n can be written as dou f by dou y. This implies f is equal to integration of n dy plus, now since we are differentiating only with y, there is remaining of x, some function g. Now this is not f of y, I'll write it as f is already done here, right? So I will write g1 of y, g2 of x, plus this is constant 1, I will say constant 2. And then you compare these two equations, because f is the same, these are both the same, is it not? These are same equation. So you compare these both and arrive at a solution. Make sense? So this is how we do it. Let us see. Now, now when we see here, okay, here, next point here, okay. So here, one of the main thing what comes here is this. Let us go further. So let us see example, right? Example, let us see, okay. Let us solve let us take one example from gate only, okay. So it's examples plus gate problems, right? So not calculus, differential equations. Fine. This has come in gate 2009. Let us see this question, okay. Have you written this down? No, not this. No, not this, not this. 2009 was wrong. So let me check out where it is. MDX plus NDY. Just a second. I did not find one. So let us solve one question here. Okay. From Crazy. This is from Crazy. Question from Crazy to explain you how the things goes. Okay. Solve x cube plus 3xy square dx plus 3x square y plus y cube into dy is equal to 0. So how do you solve this? Okay, students always read from the textbooks. Nobody can do the books like textbooks can do. I only explain, but the actual ideas are there in the textbooks. Okay, so you have to get a habit of reading from the textbooks. Okay, so this I will say again and again. So here m is equal to x cube plus 3xy square. What is n? N is 3x square y plus y cube. Now what is m? M is dou, what is m? Dou f by dou x is equal to x cube plus 3xy square. Now first we have to define, see whether if it is exact only then we can do it. If it is exact then only that function exists. Otherwise it does not exist. Okay, so what do you do? You write, see what is dou m by dou y. What is dou m by dou y? Dou m by dou y is 6xy. And what is dou n by dou x? That's also 6xy. So these are equal. So exact. Correct? Since it is 0, it's exact. Correct? No? Because it is exact, I can proceed. So here f can be written as x, you differentiate, you get x power 4 by 4 plus 3 x square y square, correct, divided by 2, correct? No, you're integrating it. I hope you're getting it. Plus function of y, because you're integrating with respect to x, plus a constant c1. I'll write it here. Over here I'll have another one, f can also be equal to, here you integrate this, okay, it's the same function, this function and this function is the same, so you integrate this. What is this? This is dou f by dou y is equal to 3x square y plus y cube. Make sense? 3x square y plus y cube. So when you have this, f would be equal to, here when you integrate this with respect to y, you get 3x square y square divided by 2 plus y cube by 3 will come as y4 by 4, correct? Plus f of x plus a constant. Let's say constant 2. Make sense? Now these are same things, is it not? Both are same. So I can write, since both are same, see, x square by 4 and f of x is the same. X square by 4 is f of x. Y square by 4 is f of y. And both has these common thing. So what is the final f of xy? F of xy can be, first write the common one, which is 3x square y square by 2. First let us write f of x. F of x is x power 4 by 4. Correct? Plus, what is f of y? F of y is y power 4 by 4. Plus a constant. Two constants adding together, I can form another constant. Or I don't know what is a constant. Constant has to be found out using the boundary conditions. So I'll write a constant c. This would be the solution. Any doubt here? Any doubt here, students? Clear? This has come a number of times in GATE. Okay. Recent times. Okay. Any doubts here? New students? Any doubts? Are there new students? No. Okay. This has become more heavy, is it? All right. Huh?
Any more basic what you can do.
Gone very slowly. Done, students?
Even though this is very weird, these are like normal, but you finished a lot.
Exactly. Revision means I'm doing a bit only. I'm not doing everything. Previously, you know the way I was doing it. I was doing one thing on different exact equation. How much time did I spend? I spent around 5 or 6 hours on the exact and inexact one. So much of time I spent. This is enough now. Forget. If I do too much of things, no, then it will go out of your mind. Enough. This much is enough. This is great. Okay. Done. So similar things are there. Later on we will see. Okay. So we'll stop it here. Or one more question we have to do. No, enough. Similar one. You solve all the gate problems. One more question you want. I'll solve it. Okay. So another question I want. Yeah, it's over here. So one more question. Let us solve. Let us solve this equation. Okay, this is a unsolved problem. This is unsolved in a Ramana. So I have to tell you where it comes from. Is it not? It's Ramana, unsolved problem. Let us see. Question is 2x cube minus xy square minus 2y plus 3 dx is equal to or minus x square y plus 2x into dy is equal to 0. Let us solve this. What is m? What is dou m by dou x? So dou m by dou y. Dou m by dou y is equal to minus 2xy minus 2. Dou n by dou x would be again minus 2xy minus 2. So it is same. So it's exact. Fine. So since it's exact, I can write dou m is equal to dou f by dou y. Dou f by dou x is equal to 2x cube minus x y square minus 2y plus 3 integrate. So you get f is equal to 2 times x power 4 by 4 minus x square y square by 2 minus 2yx, right, plus 3x plus a function of y. Similarly, dou f by dou y would be equal to, sorry, dou f by dou y would be equal to minus of x square y plus 2x, right? So we'll integrate that with respect to y. You get minus x square y square by 2, okay, x square y square by 2 plus 2xy plus a constant. Sorry, minus 2xy. I'm sorry, this is minus 2xy plus a constant, right? So minus 2xy here and minus 2xy is a common. Common we will put it here. Common, 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 common. And here plus f of x. I'm sorry, f of x, okay, plus a constant. Here f of y plus a constant I will write here. F of y is not there over here. Just function of y, is it there? Not there. Okay. Is there only a function of x? Of course there is. This and this are function of x. So I can write f is equal to minus x square y square by 2. The common terms I'll write minus 2xy common. Nodi idu mate idu common alva. This and this are common, is it not? These are common things. Correct. So now 2xy. Then we have only f of x's. F of x's x power 4 by 2. Correct. And then plus 3x. Correct. Plus 3x. And then we have a function. We can write this as constant, plus constant. Correct. Yes or no? And that function can be anything. If you multiply by another term, you can write that f another f, say f1 can be equal to 2f. Function can be anyhow written, okay? So this can be written as x power 4 minus x square y square minus 4xy plus 6x plus a constant. Write that. Okay, so that's the function. Easy. So this is how exact and inexact differential can be solved. You have to solve more problems, old gate questions you have to solve. I'm just giving you so that you should get time to study, is it not? So that's how it is. I think someone knew you got this.
Yes, sir. Yes, sir.
Yes, very good. Okay. So we'll stop it here. I'll put this on YouTube. Okay. So thank you.